All right, folks. So right now we're just going to go over this. We're not going to solve any of these. We're just going to try to figure out what equation you should use from here. They may not all be here, but we'll talk about that in a second. But if you want to pause the video right now and try to figure this all yourself and compare, I'm just going to write down numbers of these equations and see, if we can figure these out. So, number one, a bike rider is at rest. So we know its initial speed is 0 meters per second, and it accelerates at 3 meters per second squared. And for a distance, we got a position of 25 meters. What is the final speed of the bike? So they want to know this. And the equation for that would be, it's got the distance but no time, right? So it has to be this one. All the other ones have time in them. So number one is 4. All right, equation 4. What is number 2 then? Number 2, a car traveling at 10 meters per second accelerates at 2 meters per second. So its initial speed is 10, its acceleration is 2, while traveling, so it does a distance change of 100, so 100 meters per second. What is the final speed of the car? What is this? So again, that's equation 4, right? Because there's no time. So it has to be 4. It's the only one that's time independent. All right, let's do another one. 3. A boy is at rest and accelerates down a hill at 1.2 meters per second. So we got some acceleration of 1.2 meters per second squared. And it says that is originally at rest. And he does this for a distance of 50 meters. What is the velocity of the boy after he travels that distance? They want to know this. Again, that's acceleration equation with no time. So that's 4. It's going to change soon, I think. Let's see here. 4. What is the acceleration of a car that goes, okay, here we go. What is the acceleration? So they want to know this. What is the acceleration of a car that goes from 10 to 25? So initial is 10 meters per second. Final is 25 meters per second. The initial was 10 meters per second. And it does it in 3 seconds. So time is equal to 3 seconds. That's pretty much number one. Look at that. It's got the final, it's got the initial, it's got the acceleration, it's got the time. So that's problem 1. Let's do number 5. 5. What is the final velocity? There we go, right off the bat. Got a question. What is the final velocity of a car that is initially at rest? 0. And accelerates at 3 meters per second. So we got an acceleration. For 5 seconds, time is equal to 5. There we go. VVAT. It's got both V's. VVAT. That's that one right there. Number 1. Okay. Problem 6. A car at rest accelerates at. Okay, so we got a car at rest. So initial velocity is 0. Car at rest, and then accelerates at 1, and then for 10 seconds, and then how far did it travel? Delta x. Which one has all this stuff? I think it's this one. It's the only one that's got a delta x and a time. This one does too, though. And initial velocity. No, maybe it's this one actually. It is this one. Yeah, because this one does not have acceleration in it, and I don't know the final velocity, so I wouldn't be able to use it. So it's definitely number 3. Yeah, definitely number 3. All right, let me get a little space. I'm going to erase some of this real quick, and I'll go ahead and read number, what is the next one? Number 7. I'll read that while I'm erasing if I can do both at the same time. A man walks down the street at 1.2 meters per second for 30 seconds. How far did he go? Well, read it to yourself. If you want to pause and read it again to yourself. If you read, they are not speeding up. They are not changing their speed. It never says they do. It never says they change their speed. So if you read that, it just says that this is a constant, this is a velocity problem, no acceleration. It's just, they says, so they give you this, it's 1.2, and they give you, 30 seconds, they give you the time, it's 30 seconds, and they're asking for this. So I don't have that on my sheet, so I'm just going to put v equals x over t there. 8. A car travels 30 meters in 30 seconds. 300 meters in 30 seconds. What is the average velocity of the car during that time? again, that's just that's a v equals x over t equation. There's no, it doesn't say it's speeding up, doesn't say it's slowing down. It's just giving you two of the three variables and you're done. It didn't change speeds. Read it again. You can read it again. It does not change speeds. It doesn't accelerate, doesn't slow down, doesn't speed up. So you're just talking about a simple v equals xt problem. 9. How long does it take a car to accelerate from, okay, here we go. We got some stuff going on here. So it goes from this speed to this speed with an acceleration of this. And what do they want to know? How long it takes? So they want to know time. And which one, where my thing went away? Which one has those things? Two V's, the initial and the final, and acceleration of time. That's a number 3. So that's a number 3. All right. Then we're going to number 10. A car at rest accelerates from rest to 20 meters per second. What is average velocity? That's kind of a trick question. But I will tell you that it's this thing right here. Do you guys see this? This is technically, this is this is no acceleration, correct equation right here. And if I solve for this, what I do is I times t on both sides and I get delta x is equal to v times t. If something does accelerate and I know its starting speed and I know its ending speed and I divide it by 2, I add them together and divide by 2, I will get an average speed of the object. And if I times it by time, I can get the distance. It's kind of a cheat. That's why it's here on the acceleration equation sheet. Even though this is for this, you use this equation only when there's no acceleration, but you can kind of cheat and use it if you know, if you can calculate the average speed of something, then you're good. So that's what they're doing, and this is the average speed. So pretty much it says a car went from, what was it? Rest to 20 meters per second. So it goes from rest to 20 meters per second, and what's the average speed? It's 10 meters per second. Just that's the average. It went from 0 to 20. It wasn't going 0 the whole time. It wasn't going 20 the whole time. It was going somewhere in the middle, and that's why you just divide by 2 and you get 10. So for 10, I'm just going to put v plus vo divided by 2. I mean, that's the equation pretty much you need. But it is part of equation 2, so I could write that. But lastly, a train is traveling at 3 meters per second. Okay, 3 meters per second, kind of not too fast. When it starts to accelerate, kind of slow, but trains are kind of heavy, so they don't accelerate very fast. By the time it has reached 8 meters per second, how far has it traveled? So it reaches 8 meters per second, and they want to know how far it has traveled. And that has no time, so that's definitely equation 4. So go ahead and check this to yours and see if you got the same thing. And try some practice problems out.